So in this video, we are going to see a graph theory 2 marks question from the paper GATE-2012, and the topic is Dijkstra's algorithm. So let's read what the question is. Now the question says, consider the directed graph shown in the figure below. So we have a directed graph in the figure below. Now there are multiple shortest paths between the vertices S and T. So this is my vertex S, this is my vertex T, and there are multiple shortest paths to reach this vertex T. Which one will be the reported one by Dijkstra's shortest path algorithm? So when you run the Dijkstra's algorithm on this given graph, you will get one path to go from S to T, and that is the path they want. Okay. Assume that in any iteration, the shortest path to vertex V is updated only when a strictly shorter path to V is discovered. So this is one point which we can remember while running the Dijkstra's algorithm. So let's go a bit down and let's zoom in a bit. Okay. So let us start running the Dijkstra's algorithm starting from the vertex S. So I will make a note of this vertex S. Now whenever you are at vertex S, you have to assume that you are standing at vertex S, and what are the nodes which you can visit? What are the nodes you can see from S? So from S we can go to A, okay, and we can go to B. So let me make a note of it here. We can go to A with the distance 4, we can go to B with the distance 3. Okay, so we mark S as visited. So we'll mark S as visited, and we now have two options. We can go to A or we can go to B. So as per Dijkstra's algorithm, it's a greedy algorithm. We choose the shortest distance. So we go to the shorter one, which is B. So next, so A goes out of the picture. Let me just erase this. Yes. So we choose to go to B. Now here it is. I'll make a note. Mark an arrow to that. Now when you're standing at B, you're standing at node B, and what are the other vertices which you can visit? So from B you can visit D. There's only one vertex you can visit, which is D, and then you can actually visit S again, but then you have to spend 3 units of distance, and S is already striked out, so this is not something we pursue. From B you can go to D. So D is coming into the picture, and the distance will be 3 plus 4. Okay, so it will be 7. So D comes into the list, and now B is marked as visited, so I will strike out B. Now again in the list we have two nodes. We have A and we have D. A and D, and A is 4 and D is 7. So again we apply Dijkstra's algorithm. We choose the smallest value. So now I will go to A. So I will come and stand at A, and again I will come and stand at A and see the nodes that I can visit. So from A I can go to C. There's only one possibility. So C also comes into my list, and the distance to reach C will be A's distance, which is 4 plus the weight of the edge. 4 plus 1, that will be 5. So C also comes into the list, and A is marked as visited, so I'll strike out A. Now again in the list we have two values, D and C, 7 and 5. So we choose the shortest one. Let me use a different color now. So we choose C. We go to C, and C is 5. Now when you're standing at C, what are the other vertices which you can visit? So from C you can see you can go to G and you can go to E. So let me make a note here, G and E, and it will be how much? It will be C's weight. C's weight is 5. So 5 plus 2 that is 7 for G, and 5 plus 1 that is 6 for E. So these are the two new vertices which are added. And from C there is one more. You can go to D as well. Okay, it will be 5 plus 3, 8. However, 8 is greater than the already written value 7, so we never include 8 into our list. So thus now we have a now thus C is visited, so I'll strike it out. Now again we have we have 3 values into the list, 7, 7, 6. We choose the smallest one. So we go to E now. So let me come to E. Okay, let me clear this so that there is not much confusion. So we come to E now, and from E what are the nodes that you can visit? So from E we can come to only one vertex, which is T, with this value of 4. So T will come into our list, and it will be 6 plus 4, that is 10, and E will be marked as visited. So E goes out of the list. Now again we have D and we have G, and the shortest one, both D and G are having 7 values. So let's go to G. So if you go to G, I will come at G now. Now G will be, yes, from G you can go to T. It will be 7 plus 3. 7 plus 3 will be again 10. Now as it is given in the given question, as it's mentioned in the given question, that in any iteration the shortest path to vertex V is updated only when a strictly shorter path is discovered. So we have not discovered a strictly shorter path. We have discovered a path with the same value of 10. So this won't be updated. So that goes out of the list. Okay. So thus we have seen that to reach the node T, we came from S, from A to C to E to T. So S, A, C, E, T. This is the these are the nodes that we visited to reach T. So option D is the right answer.